Hello students, in this video we will be studying about the last chapter of differential equations 2 chapter, that is numerical methods to solve differential equation. Now in this part we shall consider the differential equation of the type dy by dx is equals to f of x comma y. That is the first order linear differential equations. Okay, they may not be linear, they can be non-linear also, but it is of this form: dy by dx is equals to some function f of x comma y. Okay, with the initial conditions given y of x naught equal to y naught. Now suppose y is a function. Y is a function from a domain to its range or to its codomain, I can say. Okay, now suppose x naught, x1 till xn be the points in domain, and y naught, y1 be the points in codomain. Okay, then there is we have these conditions like y of x naught equal to y naught, y of x1 equal to y1, and y of xn equal to yn. Okay, this is how we represent them. Now suppose x1 I am representing as some x naught plus h. The initial condition will be given x naught. This h is the distance between x1 and x naught. Okay, so that distance is some real number h. Now x2 is also given by x1 plus h. That means what? The distance between x1 and x2 is also h. Okay, if we see, the distance between x3 and x2 is also h. So if x0 is somewhere here, then at a distance of h we have x1, at a distance of another h we have x2, at a distance of h we have x3, and so on. So basically all these points are equidistant from each other. So basically in this part we will be considering those points and finding the values of those numbers which are equidistant from each other. That is, the distance between them should be same. For example, if a problem is given, okay, y dash is equals to some f of x comma y problem is given, and an initial condition is given to be y of x naught, let's say y of 1 is some y naught is given, value is given, and in the step of this h, at the distance of h is equals to 0.2, you are told to find the value of y of 1.6. Suppose y of 1 is given and y of 1.6 is to be found, and this h value will be given always. Wherever it is required, this h value will be given. Okay, so how you will be finding y of 1 is given, so that you will consider, then you will be finding y of 1.2, that is x1. This part will be your x1, x naught plus h. Okay, that is 1 plus 0.2, that you will write. Then using this you will go for 1.4, that is 1.2 plus zero point 0.2, it is 1.4, that you will find. And then your next step will be finding y of 1.6. Okay, so this is the reason why these equidistance point and these things are important. Okay, now we will see here a Picard's method of successive approximation. Now dy by dx is there given, suppose, then y of x naught is equals to y naught, some initial condition is given. Then to find the value of y of n plus 1, the formula is y naught plus integral from x naught to x naught is that initial condition which is given, f of x comma yn dx. This you can treat as some recursive relation also. Why? Because the n plus 1th term is dependent on the nth term. Okay, so now how we will start with such kind of problems is that, see, y of x naught is equals to y naught is given. Okay, next step is, if y naught is given, next step is finding y1. Okay, so if I want to find y1, it will be what? In this formula, it will be y naught plus 1. That is given by what? Y naught. Now this y naught, irrespective of anything, this remains constant. Okay? Plus x naught. X naught will be the term given here. X naught to x, f of x, comma. Now y n. N is what ours is, in this case it is y naught dx. Okay? So from here you will get a term y1. Now next step will be finding y2. Y2 will be given by what? Y1 plus 1. So now in this case, n value will be 1. It will be given by y0 plus x naught to x, f of x, comma, what is this y0? In this case, it is y1 now. Y1 dx equal to, this will be my y2. Okay. So in each step, what changes is this part. Nothing else changes, but this part is the one which changes in this case. Even this remains constant. Okay, so we'll see an example. Now, yes, next y3 and all will be what? It will be y2 plus 1. So obviously y0 plus x0 to x, f of x comma y2 dx, and so on. This one will go on. Okay. We'll see one example. Solve by Picard's method up to third iteration or approximation. Yes, so approximation is also called as iteration sometimes. Okay. Now, the problem is dy by dx is equals to x plus y square. Y of 0 is equals to 0 is the initial condition. And the question is to find y of 0.1 using Picard's method. Now, let's check here. Okay. If Picard's method is to be used, we have f of x comma y is x plus y square. Okay, my dy by dx is you said to be my f of x comma y in general. Okay, now y of 0 is 0 is given, so x naught is 0, my y naught is also 0. Okay, and I have the Picard's method formula. Y of n plus 1 is equals to y naught plus x naught to x, f of x yn dx. So now what I will do is I will just substitute these values here. For y1, y naught is there, next step is finding y1. Okay, y1 will be given by y naught. What is this y naught? It is 0 plus x naught. X naught is what now? Given to be 0. 0 to x, f of x comma yn will be my y naught now in this case. Okay, and what is y naught? It will be 0 dx, and it is what? 0 will be 0, so 0 to x, f of x comma 0 is what? This is x and this is 0, so y square will be 0, so it is only x that is remains dx, and that is given by x square by 2. So I have y1 to be x square by 2. Okay, now so this becomes my first answer. Now in case if you substitute y of 0.1 here, okay, y of 0.1 will be what? 0.1 the whole square upon 2. Okay, that is what? 0.005. This will come to 0.005. Okay, that so now this part, whatever you did, this y1, finding the value of y1, this is called as my first iteration. Okay, and you are told to find up to the third iteration. So although you can get an answer of what is y1 at 0.1 or what is y at 0.1, this answer is not said to be approximate. In this Picard's method, we assume that as you go on doing more iterations, more and more iterations, your answer becomes much more perfect. Okay, so this answer which we are getting 0.005 is not a perfect answer according to the Picard's theorem. Okay, so what and the question is what, up to find up till the third iteration. So what we will be doing, we'll be finding y1 here. We are not, it is not required to substitute the value. So y1 equal to x square by 2 is the equation we have got. Okay, now we'll do the second iteration. Second iteration will be y2 equal to y naught plus x naught to x f of x comma y1 dx. That is what, y naught is 0, so what remains is x naught. X naught is also 0, 0 to x. Now f of x comma y1 is what, x plus y1 square. Okay, dx. Now it is 0 to x plus, now what is my y1 square? Y1 square is this. Y1 is x square by 2, its square. It will be x raised to 4 upon 4. So y1 square will be x raised to 4 upon 4 dx. Now if we integrate, we get this to be x square by 2 plus x raised to 5 by 5 from 0 to x. That is what, if we substitute 0, the term will be entirely 0. So what remains is x square by 2 plus x raised to 5 by 5. This is the term which will remain. Okay, so this is my y2. Now this is what, with this my second iteration gets complete. Okay, we need to find till the third iteration, y3. And y3 is given by what, y naught plus x naught to x f of x comma y2 now dx. Okay, so y naught is 0, x naught is 0, therefore 0 to x. F of x comma y2 will be what, x plus y2 square dx, and it is given by integral 0 to x plus y2. Y2 is what, this one which we got in the second iteration. Okay, so now x square by 2 plus x raised to 5 by 5 the whole square dx. Okay, so now if we check, this gives us the answer 0 to x plus, now the square, opening the bracket, will get x raised to 4 by 4 plus x raised to 10 by 25 plus x raised to 7 by 5, if I am not, okay, sorry, x raised to 7 by 5, correct, dx. Okay, just a minute. Now in this previous approximation, we just forgot to take this 4 here. Okay, so 4 into 5, this 4, it is 4 into 5, so this comes out to be 20. So it is x raised to 5 upon 20. So here also it is x raised to 5 upon 20. So here also it is x raised to 5 upon 20. So x raised to 10 upon 400. And here it is x raised to 7 upon, not 5 but 20. Okay, just make that correction, x raised to 5 upon x raised to 7 upon 20. So now if we just integrate, it will be x square by 2 plus x raised to 5 upon 20 plus x raised to 11 upon 11 into 400, that will come to 4400, plus x raised to 8 upon 8 into 20, that is 160. Okay, this is my y3. So with this our third iteration is over. Now in this third iteration I will put the value of 0.1, x equal to 0.1. This is what we were told to find, right? we needed to find y of 0.1. So now in this third iteration I will put it. So what it will give me, 0.1 the whole square upon 2 plus 0.1 the whole raised to 5 upon 20, and so on. You will just have to substitute it, okay, and you will get your final answer. It will be 0.005 plus, sorry, 0.005 and something further. Okay, you will be using your calculator for this and you will be finding the answer. Now whatever this answer is, up to 4 digits after decimal point, you will have to find that. Okay, and that will give you your final answer. Now if you check in this iterations also, now if you see here in the first iteration where you found this value, it was 0.005. Okay, now in this case, if you in the second iteration, if you substitute 0.x equal to 0.1, you will get this as 0.1 the whole square upon 2 plus 0.1 raised to 5 upon 20, and that comes to, this part comes to 0.005 plus this part comes to 5 into 10 raised to minus 7. Basically, if you see, this is more accurate as compared to this one. So in the second iteration, you got it more accurate as compared to the first one. Okay. Similarly, it will be much more accurate in the third iteration. So now whatever you get here answer, that is your final answer, since it is asked to be done till third iteration. If it was to be done till fourth iteration, you would have gone one step further, and in the last iteration you would have substituted the values of x equal to 0.1. Okay, if it was about, yeah, about the second iteration only, then you would have started all these things and you would have stopped at this point only, and this would have been your final answer using the Picard's approximation. Okay, so this is about the Picard's method.